Welcome to the third video on linear relationships. And in this video, here's what I want you to get out of it. These three learning goals. So we haven't talked about gradient yet, what it is, but we need to understand that gradient is slope or steepness of a line. We will hopefully at the end understand gradient-intercept form, and the overall aim of this is to know how to sketch using the gradient-intercept method. Just for a bit of context, what are we doing? What are we sketching? Well, remember we did plotting graphs in the first video, which is using quite a few points to draw a line through those points. This first method of sketching, we use 2 points, which is like an advanced type of plotting, to sketch a graph. And in this one, we're also going to use 2 points to sketch a graph. Okay, so the first thing we have to understand is that gradient is the slope or the steepness of a graph. So, oh no, that's not a very good axis. All right. So if I have a line, this line is kind of steep, but not very steep. This line is very, very steep. So just like a hill, you can have steep hills, or you can have hills that are not so steep. You could also call the slope of these hills, how steep they are, the gradient. So this one has a very steep gradient, but this one does not have a steep gradient. So gradient, how steep something is, whether it's a line or a hill. Okay. So, and there's a number for that. So we're going to learn that there's a number to show how steep this line is. For example, this line, the steepness or the gradient is around 1, the number 1. Whereas this line is going to have a number that's less than 1. Ooh, what am I doing? And this line is going to have a steepness that is bigger than 1. All right, so gradient-intercept form, what is that? Now there's a formula that you can use to help you remember gradient-intercept form, and that's this formula. Now, let's say I have a line y equals 2x plus 1. This c over here matches up with the 1, and the m matches up with the 2. So the c is the y-intercept of the line, and this m is the gradient. So what do we know about this line? Well, we know that the y-intercept is 1. That means if I was to draw a graph, sketch a graph of this line, I could straight away label the y-intercept of that line. It has to be here. So the y-intercept is here. And we also know how steep this line is. We know that the gradient is 2. So that actually means it's going to be a pretty steep line, something like that. Okay. So if you want to know if you ever want to know what the gradient and y-intercept of a line are, you can write down the line and you write this formula above the line, and it will help you find it out. So y equals 3x plus, let's do minus 5. You can write y equals mx plus c above it. And from this we can see the gradient m is 3. And the y-intercept, you might say, okay, the y-intercept is 5. But no, because this is plus c and we've got a minus here, the y-intercept is actually minus 5. Okay. So we've done these two things. Understand that gradient is slope or steepness, and understand gradient intercept form. Hopefully you're at this stage where you know these two. If not, you can go back to the video, or you can do a bit more research. Okay, so now we're getting to this stage where we are getting up to actually sketching. Now this is my favorite way of sketching a graph, because you really have to understand, there's a lot of good understanding inside of this. Okay, so let's say we have a line y plus 3 equals 2x. Now, the first thing we need to do is make sure it's in gradient intercept form. And if you write out this line, y plus 3 equals 2x, and you write the gradient intercept form above it, you're going to realize pretty soon that this is not making any sense at all. Okay, so the y is in the right place, but the x is not in the right place, and the equals sign is not in the right place. Neither is the c. So we actually have to rearrange this to get it into gradient intercept form. So we need to use a bit of algebra to do that. And what that means is the y needs to be on the left-hand side, but nothing else is on the left-hand side. Everything else is on the right-hand side. That's the main thing we have to do. And then once we do that, we'll find that it starts to make a lot more sense. So let's do that. Where's my pen? So y plus 3 equals 2x. Like I just said, we don't want this 3 on the left-hand side because we need only y on the left-hand side. So if we want to get rid of a number that's being added on to the left-hand side, if it's being added, we need to do the opposite of that to get rid of it. We have to subtract it. So let's subtract it from the left-hand side. But the problem is, once we've subtracted it from the left-hand side, we have to subtract it from the right-hand side as well to solve that. Well, that's not the problem, that's really the solution. 2x minus 3. Okay. By the way, if anybody wants me to do a video on this algebra side of things, I'm very happy to do that. Just let me know in the comments. Okay, so we've subtracted 3 from both sides. That will get rid of this 3 over here because these two cancel each other out. So we're only left with y equals 2x minus 3. Now, is this in gradient intercept form? Let's test it out. We'll write it over here, y equals 2x minus 3, and we'll write gradient intercept form above it. Y equals mx plus c. And you can see that the equal signs are in the right place now, the x's are in the right place, and that's good. That means that m is 2. So m, the gradient, is 2, and c, the y-intercept, now is c 3 or negative 3? C is negative 3. Because this is mx plus c and there's a minus here. Okay. And by the way, adding negative 3 is the same as just taking it away. So it's like y equals 2x plus minus 3. Alright, now we can draw the y-intercept straight away. That's step number 2. We can label our axes. And the best thing about this method is, once you've got it into gradient intercept form, it's very easy to find the first point. So the first point is the y-intercept, which is where it goes through the y-axis. So it goes through the y-axis at -3, which is, it has to be here. Okay, now we are going to use the steepness of the line to plot one more point. Because we know how steep this line is. We know that the gradient is 2. And I will tell you now how to use that piece of information to find the other point. But first of all, we need to know exactly what the gradient is. So how do I get, what does it mean that the gradient is 2? Now, gradient really is how much, if I have 2 points, how much I have to go up and how much I have to go across to get to the other, to get from one point to the other. So this is the rise, how much I'm going up, and this is the run, how much I'm going across. So m equals, the gradient equals the rise divided by the run. And now this is, you might think, okay, that's a good concept, but it doesn't really help me because I have the number 2, and if we could know how much it went up and how much it went across, we could plot another point, but we don't. Now, the way to solve that is you make this 2 into a fraction by dividing it by 1. I can make any number into a fraction by dividing by 1, because 3 divided by 1 is just 3. So 2 divided by 1 is 2. So I can say, because the gradient's 2, the gradient is also 2 divided by 1. And what that means is, if I start from this point over here and I go up 2 and across 1, because 2 is my rise and 1 is my run, I will get to the second point. So that's what I want you to do. You convert it into a fraction by dividing by 1. That helps you work out the rise, which is 2, so you go up 2. And it helps you work out the run, which is 1, and you go across 1. And you've got the second point. And remember, you only need 2 points to draw a straight line. So let's draw our line, and we'll be done. But I might do one more example actually, because maybe that was a lot of ideas and not enough examples. So that's our straight line. We can draw the coordinates of this point if we want to as well. That's, the x coordinate is 1, the y coordinate is -1. Okay, let's do one more example. So let's do y equals -3x minus 4. So is this in gradient intercept form? Let's just see. We'll write gradient intercept form above it. And I didn't line that up very well, did I? Okay, so it looks like it is. C is -4 and M is -3. So straight away we can draw C on our graph. C being the y-intercept, it's where it goes through the y-axis. So we can draw that here. What am I doing? C is -4, not -3. I got them confused. Okay, let's just label that y-intercept gradient. Okay, C is -4. Let's label that here. Okay. Alright, so now we need to look at this gradient. We need to make it into a fraction by dividing by 1. So let's do that. M, which is the gradient, equals -3. Let's write rise over run first. Equals rise over run equals -3. What do we divide by? We have to divide by 1. It's the only number we can divide by so that -3 stays the same. Okay, so that means the rise is -3, the run is 1. So what does that mean? When we start here, that means we have to go down 3. Because rise is usually thinking about going upwards, isn't it? If something is rising, that's if it's positive. But if this number is negative, we have to go downwards. 1, 2, 3. And we have to go across 1 because the run is 1. All right. So that's our second point. And we can draw a line through these 2 points as well. And there we go. That's the gradient-intercept method. So our learning goals were understand that gradient is slope or steepness, understand gradient-intercept form, and know how to sketch using the gradient-intercept method. So if you have learned all these 3 things, that's great. If not, you might want to watch some of the parts of the video again. But don't watch the whole thing again, only watch the parts that you didn't understand. Okay, thanks very much for listening, and I will see you next time.